Hey, Algebra 1 class. Today we have congratulations that are in order. I've heard via Ms. Songaro and Mrs. Kamau that you guys' pre-ACT scores were really pretty good, better than they've been in the last few years. So I just want to congratulate you and tell you that this is exceptionally good news. We're proud of you. Keep working hard. You guys are learning and you are advancing in math. So keep up the good work. And we hope to see your your future ACT scores going even higher and higher. Hopefully math will become one of the very strong subjects for you as you move forward. So congratulations again. Keep up the good work. Today we're going to be using a technique for solving quadratic equations called completing the square. This method is a little different than what we've been doing, but it leads us to the same result. You remember when we say that we'd like to solve a quadratic equation, what we really mean is we're trying to find the zeros of the function. We're trying to find the x-intercepts, or those values of x for which f of x will be equal to 0. So which values on the x-axis will give us 0 on the y-axis. So this is the technique we're going to be following, and let's see if we can do a little example here to illustrate. So the basic technique that we'll be using is adding the square of half the coefficient of x. So if I have an expression that looks like this, x squared minus 18x, the question is, what can I add? What constant can I add so that this expression will factor as a perfect square? And the answer is we take 18, we divide by 2, and then we square that. And we add that in the place of c. So if I were to do that, I would get x squared minus 18x plus 18 divided by 2 is 9. 9 squared is 81. So I'm adding 9 squared. Okay? And when I do that, this thing will factor very nicely as x minus 9 quantity squared. X minus 9 quantity squared. So this is of the form a minus b quantity squared, which you know multiplies out as a squared minus 2ab plus b squared. So this is a perfect squared. X minus 9 is x squared minus 2 times x times 9, or 2 times 9 times x, which is 18x, plus 9 times 9 is 81. So this is how we go about it. Trying to complete the square will enable us to solve quadratic equations. So let's take a look here at an example and see what we can come up with that hopefully will be clear to you. So let's say that we take an equation such as x squared plus 4x equals 6. And we set off to complete the square. What would you have to add to the left side so that that would become a perfect square? In other words, notice that it's plus 4x. So we want it to be a plus b quantity squared, or a squared plus 2ab plus b squared. The answer is we add the square of half the coefficient of x. Listen to me carefully. The square of half the coefficient of x. What is the coefficient of x here? Is it not 4 right there? So what is half of 4? You take 4, you divide by 2, and you square it. Okay? 4, you divide by 2, and you square it. So we then add that to both sides. So this will become x squared plus 4x plus 4 divided by 2 is 2. So 2 squared is equal to, now listen, you must maintain the equality here. So what we add to the left, we also add to the right. We added 2 squared to the left, so we will add 2 squared to the right. Okay. So this then on the left will factor as x plus 2 quantity squared is equal to 2 squared is 4, 6 plus 4 is 10. Right there you have it. Now, here's where it gets exciting. We take the square root of the left and the right. Notice on the left we have x plus 2 quantity squared. What is the square root of something squared? It's just that thing which is being raised to the power. So x plus 2 quantity squared, the square root of that becomes x plus 2. And on the right, remember we do plus or minus the square root of 10. Okay, plus or minus the square root of 10. And if we go ahead and we solve this thing for x, we should get x is equal to minus 2 plus or minus, it's not going to let me do that, is it? Minus 2 plus or minus the square root of 10. Okay, so we have two possibilities then. We have x is equal to minus 2 plus square root of 10. This is too sloppy. Plus square root of 10, and then we have x equals minus 2 minus the square root of 10. And if you wanted to approximate this with a decimal, you would need to take the square root of 10 and then work this out. So you would have the square root of 10 is approximately equal to 3.16. 3.16. So this would be x equals minus 2 plus 3.16, or x equals minus 2 minus 3.16. And in each of these cases, it's approximately equal. And if you went to one decimal place, you would have, in the first case, you would have 1.2. And in the second case, you would have negative 5.2. Okay. 1.2 and negative 5.2. So that would give us an approximation. To be truthful, though, I think that by far the best answer is right up here. These guys right up here are our best answer. Okay, because they're exact, they're perfect representations of the value of x. You can give a decimal approximation anytime you please, but these are exact values that are very, very clear. So I would prefer that you just give your answer as follows. These ones are the best, okay, right here. All right, let's see if we can do another example. X squared minus 8x equals negative 9. Okay? We want to solve this by completing the square. Remember, the square of half the coefficient of x must be added to both the left and the right. What's the coefficient of x? 8. This is the coefficient of x right here. What's half of that? Divide it by 2, and then square that. 8 divided by 2 is 4. So 4 squared is what we will add to the left and to the right. So this becomes x squared minus 8x plus 4 squared equals negative 9 plus 4 squared. Okay. On the left now, we can factor nicely. This will work out really well to factor. So let's go ahead and see if we can't factor this now. It'll factor as x plus or minus here. Guys, is a plus or minus? Think. X minus 4 quantity squared is equal to negative 9 plus 16. Negative 9 plus 16 is 7. Okay, so 7 is what we have on the right. Now, I take the square root of the left and the right. Square root of the left is nothing but x minus 4. And then plus or minus the square root of 7. Plus or minus the square root of 7. So what are now our two answers? We will have x is equal to 4, taking the 4 to the right side, plus or minus the square root of 7. And so that could be two possibilities. X can be equal to 4 plus the square root of 7, or x can be equal to 4 minus the square root of 7. These are our two answers. So I think you can see that those are nice exact answers. Again, if you were going to do a decimal approximation, you would take the square root of 7 and work it out. Square root of 7 is approximately equal to 2.65. Okay. So if you add that to 4, you get 4 plus 2.65, which is 6.65. 6.65. And then the other answer would be x is approximately equal to 4 minus 2.65, which is going to be equal to 1.35? Yeah, I think 1.35 approximately, yeah. These are relatively simple examples. There are tougher ones that we're going to be looking at, and they're tougher. I say they're tougher because the coefficient of x squared is not always equal to 1. Notice that in these problems, as we were solving this, the coefficient of x squared was what? Right here, 1. That's our coefficient of x squared, 1x squared. It's not always 1x squared. Sometimes it's some other constant there that's not 1. And in that case, the problem becomes slightly more complicated, though not necessarily complicated. I guess it's all in how you look at complicated. It's not that bad. So let's see if we can start another problem here and do one of those that's a little bit trickier. How about 5x squared minus 10x equals 23. 5x squared minus 10x equals 23. Now in this problem, you need the coefficient of x squared to be 1. So how are you going to make it to be 1? The answer is you divide everything by 5, and then you have the coefficient of x squared being 1. So we take the left side of the equation, and we will divide by 5. And we take the right side of the equation, and we divide by 5. Dividing the left side of the equation by 5 gives us x squared minus 5 into 10 goes 2. 2x equals 23 over 5. And we're going to leave it as 23 over 5 because I don't want to put any decimals in there just yet. So let's go ahead now and complete the square. So we add the square of half the coefficient of x. What's half the coefficient of x right now? Coefficient of x is negative 2. Half of negative 2 is negative 1. Negative 1 squared is positive 1. So the left side then becomes x squared minus 2x plus 1 squared, which is just 1, equals 23 over 5 plus 1. Okay? So on the left side of the equation, we have x squared, let's do it this way, equals x minus 1 quantity squared is equal to 23 over 5 plus 5 over 5, which is 28 over 5. Okay? Needing a common denominator, so this 1 here is 5 over 5, right? So 23 over 5 plus 5 over 5 equals 28 over 5. Now on the left side, when I take the square root, I just get x minus 1. And on the right side, when I take the square root of that, I will get plus or minus. Remember, you have to do both roots, the principal root and then the other root as well. The square root of 28 over 5. And when we solve for x, then we will have x is equal to 1 plus or minus the square root of 28 over 5. So 1 plus square root of 28 over 5, 1 minus square root of 28 over 5. So there you have another example. Let's see if we can find another one that would maybe challenge us even a little bit more. Negative 3x squared minus 12 is equal to 14x. Now what they're doing in this problem is trying to confuse you. Number one, they've thrown a negative 3 in front of the x squared. Secondly, they have the 14x on the right side instead of on the left. Now before you complete the square, the first thing you want to do is get your constant on the right and your variables on the left. So we're going to go ahead and take the 12 to the right over here. I'm going to take the 12 over here to the right and bring the 14x over here to the left. So this will be minus 3x squared minus 14x is equal to 12. Okay? Just flip those two around. And then the second thing we can do, if you like, if you want to take care of your signs right now, well, it'll take care of itself, I guess. Let's just divide everything by negative 3. Remember, before you complete the square, constants to the right. Second step, make sure the coefficient of the x squared term is equal to positive 1. Positive 1. And then third step is add the square of half the coefficient of x to both sides, to the left and to the right. So we now have our constant on the right. We have our variables on the left. That's the first step. Second step, divide everything by negative 3 so that the coefficient of x squared will be equal to positive 1. So if we divide negative 3x squared by negative 3, we just get x squared. Minus, now we divide negative 14x by negative 3. So it's going to be plus 14 over 3x equals, divide 12 by negative 3, and it will be equal to negative 4. Okay? 3 times 4 is 12. So I divide 12 by negative 3 and I get negative 4. So what I've done is divide both sides by negative 3. And so the sign's also reversed. This negative here becomes positive, and this subtract 14x becomes plus 14 over 3x. Okay? Now, the square of half the coefficient of x. That's our next step. So ask yourself, what is half the coefficient of x? Well, it's 14 divided by 3 times 1 over 2. Okay? That's half the coefficient of x. So 14 over 3 divided by 2 is 14 over 6. And we have to square that. So this then becomes x squared plus 14 over 3x plus 14 over 6 squared. And that's equal to negative 4 plus 14 over 6 squared. I have to add the squared of that to both sides. This one's a little messy, you see, because it's involving some strange fractions. So what is 14 divided by 6? Well, we can reduce it a little bit. 7 over 3, isn't it? So we can make it slightly simpler. So we can write this as x squared plus 14 over 3x plus 7 over 3 quantity squared. is equal to -4 plus 7 over 3 quantity squared. So I've added 7 over 3 quantity squared to left and right. So on the left now, it should factor out nicely for us. So this would be x plus 7 over 3 quantity squared, okay, is equal to, what is 7 over 3 quantity squared? It's 49 over 9, isn't it? So this then will be equal to -4 plus 49 over 9. We need a common denominator on the right, so x plus 7 over 3 quantity squared is equal to -9 times 4, 36 over 9 plus 49 over 9. So working that out, now we have x plus 7 over 3 quantity squared is equal to -36 plus 49, okay, is going to be equal to 13, isn't it? Okay, so 9 minus 6, yeah, 13. So this is 13 over 9. And now we take the square root of the left and the square root of the right. Square root of the left becomes x plus 7 over 3. Square root of the right is plus or minus the square root of 13 over 9. Okay. And so what do we have here? We have x is equal to negative let's make that a little more clear. Negative 7 over 3 plus or minus the square root of 13 over 9. Well, what's the square root of 13 over 9? It's the square root of 13 over 3, right? Because 9, the square root of 9 is 3. So this is plus or minus the square root of 13 over 3. So we have two roots here. X is equal to negative 7 over 3 plus square root of 13 over 3. That's 1. And then the other one is x is equal to minus 7 over 3 minus the square root of 13 over 3. Now, I think you can see that we have a common denominator in these two expressions for x, and that is 3. So we can combine them together to make them look a little better. Let's rewrite those as x is equal to negative 7 plus square root of 13 all over 3, like this. Okay? And in the second case, it would be x equals minus 7 minus square root of 13 all over 3. Okay, here's our next example. We would like to solve for x in this expression. So we have a triangle. The height of the triangle is x, and the base is x plus 8. We've been told that the area is equal to 45. So I believe you all know the formula for the area of a triangle. It's 1/2 base times height. So here we go, 1/2 of the base, which is x plus 8, times the height, which is x, and that must be equal to 45 square inches. So the first thing we can do is multiply both sides of the equation by 2 to get rid of that half. So multiply both sides by 2. That gives us x plus 8 times the other x there equals 2 times 45. Okay. So on the left we have x times, I prefer to show it this way, x plus 8, okay, equals 2 times 45 is 90. So let's multiply out the left. X times x is x squared, plus x times 8 is 8x is equal to 90. Now we're down to a place where we can solve this by completing the square. Once again, what is half the coefficient of 8, or of x, sorry, half the coefficient of x? It's going to be 8 divided by 2, and then of course we're going to square that. We're going to add that to the left and to the right. So half of 8 is 4. We're going to add 4 squared to the left and right. So x squared plus 8x plus 4 squared is equal to 90 plus 4 squared. So on the left it factors nicely as x plus 4. Quantity squared is equal to 90 plus 16 is 106. Okay. Now I take the square root of the left and the right, and we get on the left x plus 4 is equal to square root of 106. Square root of 106, but we have to do plus or minus the square root of 106. Okay. So we have two possibilities for x. X is equal to negative 4, okay, plus or minus the square root of 106. So x is equal to minus 4 plus square root of 106, or x is equal to minus 4 minus the square root of 106. Okay. Now, I think you recognize that the square root of 106 is slightly greater than 10, right? Because 10 times 10 is 100. So 10 point something will equal 106, all right? So if we are subtracting, this root right here is going to be negative. The value of x would be negative. Now, going back up and looking at our triangle, can you have negative dimensions on this triangle? Could x be a negative number? No, it could not be a negative number because the measurements of sides of a triangle must always be positive numbers. They must be positive. You can't have a negative length. Therefore, we are going to rule out this second root because minus 4 minus the square root of 106 is going to be a negative answer. So this is not a possibility here. Instead, we're just going to have x is equal to minus 4 plus the square root of 106. That is the value. And if we want to know exactly what that is, we take the square root of 106, and that equals to 10.30. And if we subtract 4 from that, we get 6.3. So in this case, then x will be equal to minus 4 plus 10.3. And that gives us then again, as an approximation, 6.3. 6.3. And what are the dimensions here? 6.3 what? 6.3 what? 6.3 miles, 6.3 liters, 6.3 what? The area was 45 square inches. Therefore, we're talking about 6.3 inches. 6.3 inches. And you could check yourself out. If x was 6.3, 6.3 plus 8, 6 and 8 is 14, so that's 14.3 times 6.3. What does that work out to be? 14.3 times 6.3, and then times a half, because remember it's 1/2 base times height, times 0.5 equals 45.045, but to the nearest tenth, it's 45.0, which is exactly what we had for an area. So we are confident that our answer is correct. We've checked it out, and this is our answer right here. Okay. X equals 6.3 inches, or X is equal to -4 plus 6.3. Negative 4 plus the square root of 106. You could also use this one right here. But oftentimes when we are looking for dimensions of a figure, we would give decimal answers. So 6.3 is probably the preferred answer here, because we're dealing with a physical problem where we've measured the length of the sides of this triangle. So giving an answer of 6.3 inches is probably good. Okay, here's a problem that looks a little more exciting. It's got some fractions. But fractions are just numbers like everything else, so let's work with them and solve this. Now, you remember the steps. Step number 1, constants on the right, variables on the left. Constants on the right, variables on the left. So this then will become 2x squared minus 11 over 5x equals minus 3 over 10. So we take the 3 over 10 to the right, the 11 over 5x to the left. Now, step number 2. Step number 2 is ensure that the coefficient of x squared is equal to 1. Equal to 1. Now, right now we have 2x squared. That must be a 1x squared. So if we multiply the left and the right side of this equation by 1/2, multiplying 2x squared by 1/2 will cancel the 2. So I'm going to multiply left and right by 1/2. So I'm going to show this, even though I think you can follow, just to make sure that everybody's together. 11 over 5x, that's going to be multiplied by 1/2 as well. So this is going to be equal to 1/2 on the right times minus 3 over 10. Okay. 1/2 times 2x squared is just x squared. Okay. Subtract 1/2 times 11 over 5 is 11 over 2 times 5 is 10. So this is minus 11 over 10. X is equal to 1/2 times 3 over 10 is 3 over 20. 1 times 3 is 3, 2 times 10 is 20. So this is minus, or a negative 3 over 20. Okay, now we're ready to complete the square. On the left, we're going to add the square of half the coefficient of x. What's half of 11 over 20? Or 11 over 10, sorry. What's half of 11 over 10? Well, half of 11 over 10 is nothing other than 11 over 20. So this then becomes x squared minus 11 over 10x plus 11 over 20, and we're going to square that, okay, which is equal to minus 3 over 20 plus 11 over 20 squared. Okay, so we're adding 11 over 20 squared to both sides. Now on the left, we have x minus 11 over 20, quantity squared, is equal to, what's 11 squared? It's 121, isn't it? And what's 20 squared? It's 400. So this is 121 over 400. So this is going to be minus 3 over 20 plus 121 over 400. Now, how do I get a common denominator on the right? Well, 20 times 20 is 400. Therefore, I'm going to have to multiply the 3 over 20 by 20 over 20. Remember, I can only multiply it by the number 1. Number 1. So then this is going to be equal to x minus 11 over 20. Quantity squared is going to be equal to 3 times 20 is 60. So this is going to be minus 60 over 400 plus 121 over 400. So negative 60 plus 121 is 61, isn't it? So this is x minus 11 over 20, quantity squared, is equal to 61 over 400. And now I do square root of left and right, and I get x minus 11 over 20 is equal to plus or minus square root of 61 over 400. We can simplify that just a little bit because the square root of 400 is 20. 20 times 20 is 400. So this becomes x equals 11 over 20 plus or minus the square root of 61 over 20. So I have two roots now. X is equal to 11 plus square root 61 over 20, or in the second case, x is equal to 11 minus the square root of 61 over 20. And let me just work out decimals for that, for those of you who are interested. So after calculating these, figuring the square root of 61 and then calculating these, we get that x is approximately 0.94 or approximately 0.16. I think I'd prefer to see them exact. Here they are, right here. This is what we want to show. These are our exact roots. So I think these are the better answers. 11 plus root 61 over 20 and 11 minus root 61 over 20. So here are our two answers. Okay, now there's one last thing I'd like to do. Let's take this problem now and let's look at it in the Desmos graphing calculator and see if we get anything like this. I want to make sure you do not lose touch with the fact that we are finding roots to a quadratic equation. Roots to a quadratic equation. Therefore, if you look at the graph, you should find that the graph is crossing the x-axis at approximately 0.94 and approximately 0.16. When I say approximately, you know, there's a whole string of decimals you can put there, but basically it's 0.94 and 0.16. So how would we go about doing this? Okay, let's go back up here and look at our original equation. 2x squared minus 11x minus or plus 3 over 10 is equal to, and we set it equal to 0 when we solve for x, but we don't want to set it equal to 0 when we're going to graph it. When we're going to graph it, we're not setting it equal to 0, we're setting it equal to f of x. So let's take a look at this original function right here, this guy right here, and let us work through it. As a quadratic function, okay? So 2x squared minus 11 over 5x plus 3 over 10 equals f of x. And then, of course, we're going to look for f of x equal to 0. So when is it equal to 0? Okay. So that's the problem. That's what we're going to be doing. So we want to switch ourselves over here to the Dismas graphing calculator. All right. So f of x. What's another word for f of x? Y, isn't it? But we can still write f of x. 2x squared minus 11 over 5x 2x squared minus 11 over 5x plus 3 over 10 equals f of x. And of course, we want to know, where is this equal to 0? Well, there are two roots, correct? Two roots. Because you can see there are two x-intercepts. That's why we say there are two roots, two x-intercepts. So if we come over here and we zoom in, you can begin to see where those roots are. Let's look here. Okay, the one is right here. See if we can identify this guy. Negative 0.1595, comma 0. So this is the first of our two x-intercepts. Notice the y-coordinate is 0. Of course it's 0 because that's the y-coordinate of an x-intercept. It's always 0. So 0.1595 or 0.16 approximately. And then the other one is up here. And what is this one? It's 0.94. So 0.16 and 0.94. You see this? 0.1595 or 0.16. And up here 0.9405 or just 0.94. Does that correspond to what we found mathematically solving? Come over here and we zoom down again and see what were our solutions. We had 0.94 and 0.16. See this right here? Pretty cool. We have 0.94 and 0.16. Right here are our two answers. See that? 0.94 and 0.16, corresponding exactly to what we had on our graph. 0.16 and 0.94. I think that's pretty cool. I hope you're impressed. It's very nice. Okay, let's go ahead and do one more. This will be our last problem. You may already have this and maybe you're good to go already, but if you're still a little confused, let's do one more. So 1/4 of x squared plus 2x. Okay, here's another problem. 1/4 of x squared plus 2x is equal to 3/8, 3 over 8. Okay. Our job is that we would like to solve this for x again. We want to solve it for x again by completing the square. So we've already completed step 1, or it's completed for us. The constant is on the right and the variables are on the left. Second step, we need to make sure or ensure that the coefficient of x squared is equal to 1. Right now it's not 1, it's 1/4. What do you have to multiply 1/4 by to get 1? 1/4 times 4 equals 1. So I'm going to multiply the left side of this equation and the right side of this equation by the number 4 to eliminate that fraction in front of the x squared. So 4 times 1/4 x squared plus 2x is equal to 4 times 3 over 8. Okay. In the first case, 4 times 1/4 is just 1, so this is x squared, plus 2x times 4. What's 4 times 2x? Be plus 8x. Okay. Equals, on the right side, 4 times 3 is 12. So this is 12 over 8. Okay. Now I'm ready for step number 3. Step number 3 is going to be to add the square of half the coefficient of x to both sides. The square of half the coefficient of x. So in other words, I'm taking 8 over 2, half of coefficient of x, and I'm squaring it, and then I'm adding that to the left and to the right. So this is what we add to the left and to the right. The square of half the coefficient of x. Remember, this is the coefficient of x. Half of it, square that, add it to the left and to the right. So this becomes x squared plus 8x plus, what's 8 divided by 2? It's 4, right? So we're going to add 4 squared to the left and to the right. So 12 over 8 is actually equal to 3 over 2, correct? If you reduce this, 4 goes into 8 2 times, 4 goes into 12 3 times. So this is 3 over 2, 3 over 2. So this is 3 over 2 plus 4 squared. Okay. So working our way down now on the left, this is a perfect square, which is what we've been doing all along. It's why we're doing it. This is x plus 4 quantity squared. Okay. Equals 3 over 2 plus 16. Well, 16 over 1 is equal to 32 over 2. Multiplying 16 right here, we're going to multiply by 2 over 2 so that we get 32 over 2. So then on the left side, we'll have x plus 4 quantity squared is equal to 3 over 2 plus 32 over 2. So in the end, we have x plus 4 is equal to, let's go ahead and keep the square on there for now. X plus 4 quantity squared is equal to 32 plus 3 is 35 over 2. Then I take the square root of the left and the square root of the right. Square root of the left, x plus 4 is equal to plus or minus the square root of 35 over 2. The square root of 35 over 2. So x is equal to minus 4 plus or minus square root of 35 over 2. Okay. So I have two roots. X is equal to minus 4 plus square root of 35 over 2, and x is equal to minus 4 minus the square root of 35 over 2. So in the first case, this is approximately equal to 0.18. So we jump over to the Desmos graphing calculator and we take a look at it and see what does that look like. Here we go, Desmos graphing calculator right here. So I've already put the function in. F of x equals 1/4 of x squared plus 2x minus 3/8. This is a parabola. Notice that the 1/4 is a positive number. Therefore, the graph opens up. It opens up. And it turns out that we have a vertex right down here of -4 and -4.375. It's opening up, therefore we have two roots, two zeros of the function. Here are the two zeros of the function. You zoom in on this a little bit so you can see them closely. So this is -8, this is -9. This would be -8, -8.2, -8.4, -8.6, -8.8, -9. So this, notice, is just slightly. -8.2 is here. This is just to the just to the right of negative 8.2, which would be what? Negative 8.183. To the nearest hundredth, that's negative 8.18. So you go over here to the other side, you say, where was this other root? Right here is the other root, just a little shy of 0.2. What is this root? 0.1833 to the nearest hundredth, it's 0.18. So isn't that cool? This quadratic function has a graph of in the shape of a parabola. It's opening up. It has two x-intercepts or two roots, which happen to turn out to be negative 8.18 and 0.18, which just coincidentally, happens to be exactly what we got right here, using strictly mathematics through completing the square. I hope that clears things up for you and that you're beginning to understand what roots, zeros of the function mean, how you can complete the square to solve for those roots. Completing the square turns out to be a really nifty tool that allows us to do some pretty cool stuff. All right, well, good luck in your homework. I hope this will make it easy for you, and I will be around through WhatsApp if you have questions. All right, good luck in your assignment. Again, I'll be available through WhatsApp if you have questions.